Hi everyone, welcome to this video on calculation of power consumed in resistors and AC circuits. So let's dive into two main questions. In the first question, it says to calculate the actual power consumed by a 110 volts fan rated at 100 watts when connected through a 25 meters cable with 2 ohms resistance. So when it says that this fan is rated at 100 watts, it's telling us some information about its internal resistance or its ideal current that can tolerate. So in that sense, we have the relationship between the power and the voltage as follows. So P equals V times I, and in this case, in ideal case that the fan is rated, we have the voltage of the fan is at 110 volts, which means that if the fan is connected to a 110 volt power supply without any losses in between, it can produce 100 watts of power, and in that sense try to find the current, the ideal current passing through the fan. So in this case, I becomes 100 over 110, which is around 0.9 amperes. So this is the ideal current that is passing through this fan. Now, it's asking that when this fan is connected to a cable that has 2 ohms of resistance and also to 110 volts, what would be the actual power consumed by that? So let's draw a circuit diagram for a better understanding of this whole scenario. So imagine that again, this is the power source that is connected to a fan on the right side and with an internal resistance of the cable as 2 ohms as shown here. So the question is, let's try to find the power that is consumed, or PF, by this fan. So we know that what is the amount of current passing through this fan. And if you want to find out the same current passing through the resistor, we can find out the voltage drop across that resistor. So in order to do that, if I want to call this as R, and the voltage drop across that as VR, so VR essentially is 2 ohms times I, that in this case is 2 times 0.9, which is 1.8 volts. And imagine that the source is 110 volts, as we started the discussion with. So in order to find the power consumed by the fan, we can first of all get to the voltage drop across the fan with subtracting the voltage drop of this cable from the power source. So in that case, we can get to the V of F. So once we get VF, we can then multiply this VF by this I to get to the total power consumed by that fan. So in that sense, let's try to find the voltage drop VF first. VF is essentially 110 minus VR, which in this case is 110 minus 1.8. It becomes 108.2 volts. Now that we have the voltage drop across the resistor, we can find the power consumed by that, by the fan. So power of fan is essentially VF times I. And I is the same as we started our discussion with before, as the ideal current passing through the fan. So it is 108.2 volts times 0.9 amps, which takes us to around 97.38 watts of power. So essentially, this is the total power consumed by the fan in this scenario. So let's move on to the next question. So next question is saying calculate the total power consumed by 4 240 volt / 150 watts lamps connected in series to a 240 volt AC source. So in that case, what we need to do to find the total power consumed by 4 lamps is essentially, first we need to find the resistance of each lamp because we are giving the voltage and wattage of each lamp in our ideal case. These are rated values, so we can find the resistance of each lamp and then multiply that by 4 to get the total resistance of the lamps. Now that we have the total resistance, we can then find the total current passing through the whole system. And when the total current is calculated, and the initial voltage is given as the AC source voltage, we can then multiply them to get to the power. So let's do that step by step. So for each resistance, we have 240 volts of voltage and 150 watts of power. And the relationship that relates them together is P equals V squared divided by R. Now that we have both V and P, R then becomes V squared divided by P. So in terms of voltage, we have 240 volts squared divided by 150 watts, which takes us about to 384 ohms. So this is a resistance of each one of these lamps. Now that we have 4 lamps in series, so we can assume that we have 4 identical lamps in series that are connected to a voltage source R 4 times. I can equate that with an R total that is again connected to a source. And since these resistors are in series, RT is equal to R plus R plus R plus R, and essentially it becomes 4R. And in our example, it becomes 4 times 384 ohms. That takes us to 1,536 ohms. Now that we have the total resistance, we already know that the power source is 240 volts. That takes us to the total current. So the I total, which is the same as I of each resistors because they are in series, is simply the V total or the VS divided by R total. And in this case, 240 volts divided by 1,536 ohms takes us to about 0.15 amps of current. So that's the total current. Now that we have the total current and we have the total voltage, we can then find the power of total system as V total times I total. So V is essentially the total voltage of the source, 240 volts, times the current, 0.15 amps. That is around 37.5 watts of power. So essentially the total power in the series connection of 4 lamps is essentially 37.5 watts. Okay, so now that we are done with these 2 examples, we have 3 more exercise questions that you are welcome to think about them and solve on your own. And if you have any questions on them, please leave a comment or ask, and then I'll be able to respond. Thank you for watching. If you like such videos, hit like and subscribe to the channel for more videos in the near future. See you soon.